Listen, that satisfying click when you close the lid of your earbud case, the firm magnetic pull of a wireless charging dock, or the smooth vibration when you type on a touchscreen. We enjoy these physical feedbacks every day without giving them even the slightest thought. But right now, behind those familiar sounds, the world's superpowers are entering a ruthless battle. They are not fighting over oil or semiconductor chip cores. What they need is the invisible heart that creates those movements. Neodymium rare earth magnets, tiny 010, no bigger than a fingertip. Yet they hold the life of modern technology in their grip. Welcome to Everyday Things Explained. The curse of the twins. If the formula already exists, why not just make it yourself? Start with the name. In Greek, neodymium is formed from two words, neo and didymos, twin. It reflects a harsh truth. Neodymium always clings to another element, praseodymium. Like conjoined twins, they stubbornly refuse to be separated. The problem is not simply digging rock and soil out of the earth. To separate them, the ore must pass through chains of toxic chemical reactions and expensive refining filters. Having an ore deposit is one thing. Turning it into a magnet block that can withstand millions of cycles of friction inside a motor demands a massive metallurgical ecosystem. The silent world. Imagine this. If every neodymium magnet disappeared right now, what would happen? Your phone would instantly lose its speaker and its vibration. Computer hard drives would go dark, wiping out every piece of data. Camera drones in the sky would drop like figs. Millions of electric vehicles and industrial robot arms would become blocks of scrap metal. The modern world would sink into paralysis in just 1/1000th of a second. The power of neodymium lies in its density. It stuffs an enormous magnetic field into an ultra-tiny space. Machines become lighter and more compact because of it, while their power multiplies. The supply chain weapon. This very power turns neodymium into a geopolitical weapon. The world is not running out of ore. The problem is, who controls the machines that process it? For decades, this closed-loop supply chain has been seized. Now, strangling supply no longer requires an embargo. Billion-dollar factories run on schedules measured in minutes. Just one delayed shipment of magnets, and the production line stalls, while thousands of workers can only stand and watch. The world suddenly realizes the power switch of the future is not in its hands. Recycling is not as easy as taking apart Lego. So why not take magnets from old electronics? The idea sounds reasonable, but reality is messy. Magnets inside earbuds, hard drives, motors, or phones are often glued, pressed, sealed, or buried deep inside component assemblies. Products are designed to be thin, durable, and cheap when sold, not to be gently taken apart after a few years. To recover magnets, people must gather enough devices, sort the right materials, and process them through a dedicated method. If done poorly, the cost can be high, while the amount of recovered material is too small. Today's convenient design can become tomorrow's recycling problem. The invisible pulse. The magnet crisis is a cold splash of water, exposing just how fragile the global technology system has become. Next time, when you close the lid of your earbud case and enjoy that familiar click, remember this: you are touching the endpoint of a powerful supply chain, geopolitical calculations, and the absolute limits of mechanical engineering. The most important part is not always the biggest one. Sometimes, it is the thing no one can see until it disappears. Thank you for watching Everyday Things Explained. See you in the next video.